Good evening, everyone. Welcome to CodeRally 5.0, organized by the IEEE Computer Society Student Branch chapter of IIT. In this series of 5 workshops, we'll enhance our problem-solving skills. I'm Nilasi Jayatilaka, and I'm thrilled to be here with you all today as your moderator. We are starting with an exciting workshop on competitive programming, the first in the series of 5 engaging workshops. Today's session focuses around competitive programming, where you learn techniques that will definitely benefit you beyond this workshop. Please find the link on the chat to submit your questions and share your thoughts. We will have a dedicated Q&A session later. Well then, let us give a warm welcome to our speaker, Mr. Sunera Avinash, co-founder, director, and CTO of IXT Labs. He will be guiding us throughout this workshop. And sir, we are truly grateful for your presence here today, and we look forward for the insights that you will be sharing with us. Mr. Avinash, this virtual stage is yours.
Okay, can you hear me?
Yes, sir. Your audience.
Okay, thank you. I hope my screen is visible as well, right?
Yeah.
Okay. So so in this workshop, so in this presentation, like I'll be mainly talking about introduction to competitive programming. So first of all, I'll introduce myself. So I am Sunera Avinash, co-founder and CTO of ISD Labs, which is a company we founded. And back in the university days, our team, Code Breakers, managed to win awarded coders, access coders, and many national and international competitions, mainly competitive programming competitions. And first of all, like before starting anything, I guess I have to introduce what is competitive programming, because I hope some of you might be already familiar to the term, but some of you might be like it may be the first time hearing that. So, what is competitive programming? So that's a huge description, a text block, but in a nutshell, competitive programming is something like solving process, right? But the only difference is you have to do it with code. So there are a lot of competitive programming competitions, Sri Lankan ones and many international ones, and all revolve around something like this. The format is like this. So you have a period of time, for example, let's say 24 hours or 12 hours, and in that time you have a set of questions, right? So you have maybe 24 questions, so 10 questions, or something like that. What you have to do is basically solve each of the questions, and basically you have to submit a code that solves the problem. You have a given problem, and you have to submit the code that will solve that. And your code should run like take the input and process it and output the result, and do it so within the time bound that they have set. For example, your program should complete all the test cases, maybe each test case within 2 seconds or something like that. So likewise, that this is the competition that mainly focuses on your problem solving ability, right? So you have to be able to solve problems, and you should be able to like learn and develop your algorithm skills, data structure skills, programming skills, and puzzle solving. So what do you get from like a competition like this, right? Obviously you get gifts and prizes if you win, and you get memories. And even today I have memories of those days, because it's a 24-hour time, right? So whole day you don't get to sleep or something. So in that time it's like it's very stressful, but it's also very fun, right? Because you have friends there. and you are all like thinking how to solve this problem, how to solve that problem, and like it's always like very exciting. And whenever you get some points, you get this, rush that yeah, I did that, and that is a very like exciting feeling. So that memory is very precious, and I'll say maybe even more precious than the gifts and prizes that you get. And another thing you get is basically to stand out in interviews, right? So because like there's a huge competition out there, so you need to be able to like stand out among others, and winning in these competitions and going to these competitions is a very great way to like make yourself like unique. And obviously you get recognition if you win, and for our lasting team. So even our company, like the ISD Labs, we formed it like from the team that we went to the competition that in the university days also, like that, because you get all together, right? It's all people that love to solve processes and love to program, and you develop your skills together, and even after university that team will last. So those are the main things you will get. Obviously there are others, but I'll go to this slide quickly because there are a lot of slides. Yeah, and in this competition, like what type of questions you get? So, for example, you get. So I'll be going to these like I'll be only mentioning these types of questions. At the end, I'll give mainly like tips and tricks and some books you can follow. And in the presentation will mainly consist of data structures and those kind of things. So I won't be going into the advanced stuff, but I'll give you a pointer to follow up on where to learn those advanced stuff. So in all competitive programming questions, you get like some these kind of questions, right? So main type of questions are algorithm application and data structure application. So algorithms like the RSPD algorithms, divide and conquer, and there are data structures like trees, graphs, and in the competition, what you are given is mainly a problem that revolves around like how to innovatively like apply all those theory stuff you learn. And obviously you get mathematics and theory applications, for example geometry, combinatorics, game theory, and those kind of stuff as well. So these mainly revolve around your mathematical ability. So whether you can like basically understand the question and maybe derive an equation for that, something like that, or maybe understand what is the easiest or the mathematically easiest way to arrive at the problem, or something like that. And then there are interactive problems and puzzles. These are mainly like I have seen them mostly in IEEE Extreme. Those kind of competitions, they are given a puzzle kind of solution. Even there was a time that they gave a question that didn't have like a proper question text. They give us the output and tell us to figure out the uh, program, something like that. So those are kind of puzzles. So those are very different kind of branch. But other things are algorithm applications, data structure applications, and mainly mathematics. So yeah. So first of all, I'll be looking at data structures, time complexity. Like this might be somewhat boring stuff, but it is necessary to get to this because you have to learn your techniques before you go in a competition, right? So uh, for this section, my I am assuming that you have some kind of programming language knowledge. It doesn't matter what language. If you know what language, I think it is enough. And maybe you are new to competitive programming, then that's fine too, because uh, I'll be mainly focusing on the basic stuff, not the advanced or intermediate level, but the basic level. And it is better if you have already an idea about time complexity, data structures, mainly a theory part, because I won't be discussing theory today, right? So because in competitive programming, theory is enough. Theory is like you need theory, but like to go for like most of the way, what you have to have the knowledge is the knowledge to apply them, right? Having the theory will get you the rest of the 10%, but for the 90% of the way, what you need is like the application part. So I will be focusing more about the application part and how each data structure may be, algorithm may be, how each of those things apply to competitive programming. Not, I won't be discussing how they internally work. So yeah, why data structures? So competitive programming is, in my view, a combination of these three. It's algorithm plus data structures plus puzzle solving. So you have your data structures, that is kind of like the arsenal you have, like what are the tools you can use. And then you have algorithms. Algorithms are like what are the strategies you can use. And then you obviously you should have puzzle solving ability. So if you know more data structures, then obviously you have a big advantage over others, because if there's a person who only uses one data structure, he's like very largely limited in what they can do. So if you know more data structures, if you know more algorithms, then you have a very good advantage over others. But that said, that you can use one data structure to implement any algorithm, because algorithms, those are like it is, you can do them, like you don't have to learn like all the structures there is. You can use one to every scenario. But uh, why then the question is, why do we need other structures, right? Because if we can implement any algorithm using just maybe arrays, then do we even need other test structures? The problem we get, uh, like yeah. So we, the reason we need data structures is mainly the reason I stated here. Competitive programming is not about solving the problem in any manner possible, like, because you will be given a question, but it doesn't matter like you write a program like to solve it. But the problem is you have to do it in a set of time they give. So for example, as I said before, they maybe say, okay, your program has to run in 1 second for this question. So your program has to run like efficiently as well. So when you go into competitive programming competitions and you submit answers, you get these three kind of things. It may like the platform, maybe HackerRank or something like that. It will give out maybe either wrong answer or runtime errors or timeout. But the thing is, if it is wrong answer, that means obviously we understood the question wrong, right? So we have to visit the question again and understand why it gave the wrong answer. If it is a runtime error, that means okay, there are some cases we didn't handle. Maybe there are edge cases. Maybe there are, like for example, division by zero. So we have to handle them. But the other case is timeout. That is like the platform telling you your program is too slow. This is like dreaded, because the main reason is this says that your approach may be entirely wrong, or this may be telling you your approach might not work enough for these test cases. And maybe you didn't use the direct, like the correct data structure, maybe you didn't use the correct algorithm, so you need to revisit it again and think again. And to understand and to battle this timeout issues, you have to know what operations are slow or fast in data structures, and you need to know what algorithms are slow and fast. And you have to think on the program and the input sizes, and you then you can only like pick the most suitable one. So this was like the introduction, right? So mainly uh, today I'll cover mainly time complexity and data structures, and if I have time, I'll cover algorithms as well. And to discuss data structures, I need to, like, as I said before, you sorry, you need to know what operations are slow and fast, right? So how do we determine uh, slowness or fastness, right? So in that case, we use time complexity. Time complexity is uh, mainly talking about like how we can compare each operation. And in data structures, there are like primitive and non-primitive ones. I won't be discussing obviously primitive ones. I will be discussing hash sets, text, those kind of non-primitive ones. And I will talk about data structures and situations to use them, but I won't be talking about how they internally operate. Like for example, I won't be talking about how hash sets work underneath, but I will be talking about how you can use hash sets in a computer programming competition. So yeah, so time complexity. How many of you guys are familiar with the term big notation? I can't see the screen here, but yeah. How many of you are like, can I have a raise of hand? Yeah. Okay. There are people. Great. Then that's easy for me. So, uh, you need like obviously for to become become like expert in this like competitive programming, like you need to have a very good idea of big notation, because we need to like we need a metric, like we need to have a metric to discuss what operation is slow, what operation is fast. So you can't talk in seconds or something like that. In algorithms we use big notation. And I said before, like I said before, I won't be going into like the theoretical part, mathematical part of what is a big notation, but the intuitive idea is something like this. So how the operation scales with the input size when you take the worst case. Like for example, when like write an algorithm, in the worst case, how slow would it be? Like it is the max bound, right? We are talking about the maximum slowness basically that the algorithm can take. So that's why I have embedded the video here. You can watch. I'll share the slide link at the end, so you can like watch the video at the like at your time. But that is the intuitive idea. So uh, so these are the notations we use. We say big of one, basically saying it is a constant time operation, which means no matter how big your input is, it will take the same time. Like if you have one one like input of one is, let's say, one element, then it's not 10,000 or million, no, it doesn't matter. Big of that. Big of log n is basically saying the time is like it changes in log n time. So for example, if I hope you know logarithmic. So basically, if it takes 1 second for 10 array elements, for 100 array elements, it will take 2 seconds. For 1,000, it will take 3 seconds, something like that. So it is still fast. So you can see in the graph here, in the green part, it is big of 1 or big of log n. So these two ones are the, we'll say like very fast operations. Like if your algorithm is log n or big of 1, that means it's perfect. Like it's really great. And then there is big of n, which means your time grows linearly. So for example, if there are 10 elements and it takes 10 seconds, for 100 elements, it will take 100 seconds. For 1,000, it will take 1,000 seconds. So this is okay. I mean, the great problem or as still like, but this is worse than the n log n, which means like it goes in this manner, right? So in this chart, you can see it's in this yellow area, the bad area. And then there are the really bad ones. So n squared, n cubed, and exponential and factorial. So these ones are like, we say like in terms of complexity, they are like we say slow. But how to apply this knowledge in a competition is like this. So in each competitions, most of the time, like I'd say 99% of the time, they give in the problem the constraints, right? So they say, okay, mm, in the question, the number is so something like something they mentioned, it is between 1 and 10, 1 and 1000, 1 and 10 to the 5, or something like that. So for example, you can see in the example I shown here, it is saying the S is between 1 and 10 to the 5. So something like that. So from that, you can basically like guess what kind of time complexity they expect, and from that you can actually guess what kind of approach they expect, right? But the thing is, like, this is not a silver bullet. This like, it doesn't work always, but most of the times you can actually get an idea, or uh, like an initial guess, even without like seeing the question. So how it works is like this. So if you have a input size less than 20, like it says S is less than 20 or something like that, then they expect the factorial or exponential one. So in this chart, they expect these two. If the n is less than let's say 20, because in most of the times, if it is less, like then when n is bigger than 20, if your algorithm is in this range, it will mostly time out. So if they say explicitly, okay, the n is between 1 and 20, that means they expect you to use maybe they don't like, they expect you to have time complexity of this. So that means you can try all the permutations, you can try all the subsets, so like you can try all the combinations. Basically these time complexity come from them, right? So that means either the question is very easy or very hard, because when they give something like this, that means there is no easy way. You have to get the answer in like a very like computationally heavy way. That means either they don't care. That means the question is a very easy one, or um, like it will be a very hard one. And then there is n less than 500, which means cubic. They expect cubic time complexity, which means you probably have three nested loops somewhere in the code. Like these are like probable things, right? We can't exactly say, but most of the times, if n is less than 500, that means there is probably three nested loops. And if n is less than 5000, that means it is in squared, so which means there are probably two nested loops. And if input size is less than 10 to the 5, that means n log n, which means they are probably sorting. So probably you have to sort something inside the code. Maybe you have to sort the input, or there is a data, like you have to use a data structure that takes log n time. So that's what it says. And if n is less than 10 to the 7, that means time complexity is linear. They expect a linear time complexity, which means you can have one loop only. Like you can't have nested loops. If you have nested loops, that means like it will time out. And if your input size is like, if they tell you n is less than, let's say, 10 to the 9th or something, that means the problem is either something like binary search, or there is a straight equation, like equation that you can plug the values and get the answer, which means there is no like loops or anything like that. So in this question I have shown here, it says 1 and 10 to the 5, right? So which means it probably involves sorting or data structure, like that. Like you can actually guess the approach even without seeing the answer, right? Like the seeing the question. So that's why big connotation is very important. And in the next section, I will discuss their structures, and we will use big connotations there as well. So first, basic data structures. So these things are the most basic ones: simple variables, arrays, text, queue, linked lists. So if you are like familiar to programming, then you probably already know several data structures already. But there are several that we commonly use in competitive programming competition, so I'll explain them. So first one is like stack and queue. Stack and queue are like one of the most basic data structures. Um, so from like stack means stack of plates, something like that. So you put the plate at the top, and you can't take the plate at the bottom, right? You have to take the plate at the top always. So last in will be the first out. So stack is a structure that can push elements at the end, and you can remove the elements at the end. You can't like remove the element at the first. And the other data structure is queue. Queue is first in, first out, which means like queues, right? So first one to join the queue will be the first one to leave the queue. So in here as well, I have shown like stack is something like this. You put elements at the top, and you get the elements at the top. And in a queue, you put elements at the top, and from the bottom you will take out. So first in will be the first out. So I hope you are familiar with Python, right? Because I am explaining the data structures using Python. So, but it like in any sort of programming language, like no matter Java or C++, so those are the most common ones. C++, Java, or Python. Those things are the most common in competitive programming domain. So, no matter what your language is, like you can do these things in any programming language. I am just using Python because like it is in Python, most of the stuff is easy. And in competitive programming competitions, like you have to remember, they don't test your programming ability, right? They don't test if you know Python, if you know Java, but they test is if you know this algorithm, or if you know this data structure, and if you know how to apply those stuff in a creative manner. So in most cases, you will be fine with any programming language. Obviously, there are cases where they are like you have to use a specific language for something, but in most cases, you will be fine with any language. So yeah, I'm using Python, which I think is great if you are a beginner for competitive programming, because most of the data structures and algorithms, like it is easy to write them in Python. C++ or Java is also good. They are also good choices. C++ and C, those things are actually the ones most commonly used by the advanced one. So yeah, in Python, here's how you can implement a stack. So you can simply use a list in Python, and you can append stuff and pop stuff. Which so here list will act as the stack. And for a queue, you can use the queue data structure from collections package, and you can append stuff, and pop left will get the first element out. And then I'll talk about arrays, which I am assuming like everyone knows. So arrays is an like data structure in which we can store stuff using an index. So index is basically more in most programming languages, index starts with 0, 1, 2, and goes on forever. And you can store stuff and get, and you can actually insert or delete stuff from the index as well. And I have seen that like because arrays are the most commonly like known thing, in most of the cases people use arrays for every situation, but it is not suitable because for example, this is the one case that I have mentioned. If you need to constantly search elements, arrays are not suitable. So for example, if you have maybe let's say you have a list of items, and in a loop you are searching if the element is inside the list. So if you do that, like searching in an array is on, which means if you have it inside the loop, it automatically becomes on or n or some or n squared. So automatically becomes polynomial time. So if you use arrays for searching element, when that array or the list gets bigger, the time to search will also take more and more, which means when you submit the uh, code, it will most probably time out. So if you constantly need to search elements, arrays are not suitable. There are other data structures for that. But even arrays you can keep, for example, this is the one way you can still use an array, but not be, for example, not have this complexity. So you can have the elements in login. It's like if you have an array, first sort it, then search using binary search, and that will take login time. So which is much better than the ON one. So for example, if you have a list and you have to constantly search in that, first you can sort, then search. But obviously you have to remember that if you sort something, it will take n log n time, and yeah, that will be the algorithm, the time complexity. But uh, if you search in an array in a loop, it might be a line. Like if you write, when you write the code, you will see that okay, in Python you have to say if I in list or something like that, and you will see okay, it's just a line, right? But that line will take on time. That's the point. So don't use arrays for constantly searching elements. Obviously there are special cases, but I'm talking about the general case here. So in general case, searching in an array is slow. So for that purpose, we have another data structure called hash set. So in hash set, what it has is unique element. So obviously, if you have duplicated items, you can't use hash set. You have to use an array or something like that. But if you have unique values and you need to search elements in that data structure, hash set is the answer, because you can insert items, delete items in no one time, constant time, and you can search for a particular element in no one time. So that means like it doesn't even like impact your code. So the only catch is you can only add unique items, and there is no preserved order. But in most of the cases, if you are what you're doing is searching, then hash set is more than enough. And another variant of the hash set is hash map, which is a data structure in which you can store keys and value pairs. So for example, in the diagram I shown here, you can like the diagram I have shown like how it works. Like so, it's using a hash function. Basically, you can like store key value pairs. So, example, in banana, the value is one, and apple value is two, something like that. The only problem is you have to like only catch is the key should be hashable. For example, strings, like for example, you can't use list as the key. You have to use something very simple variable like uh, strings, numbers. Those things are the only possible things for keys. And just like hash set, this also has theoretical or one-time complexity. And just like hash sets, the catch is you can only store unique keys, and there is no preserved order. For example, if you put one key and the second key next, when you get them, you will probably like we can't say it's random. So you might get second element first or first element first. So there is no preserved order. And this is how you can implement a hash set and hash map in Python. So there are already a set. You can use set for hash set. You can add the limit, and dictionary, like it is the map, hash map in Python. We call it a dictionary. So you can use it like this. Okay, so I'll be moving on to some more like advanced data structures. These ones I won't be discussing like in depth. I'll be only like discussing them like what are they? Like basically, I'll be saying what these things are, and uh, just so you know the word, right? So you will know when to use them. So graphs is one data structure that we commonly get in the, like computer programming competition. So graph is something like a road network, right? So example, say if you're like problem has something like there is a set of cities and there are roads between them and vehicles travel between those cities. That means it is a graph problem, most probably. And the graph data structure is something like this. So you have a set of nodes. Basically, in this picture, A, B, C, D, those are nodes. And in those between those nodes, there are edges. Basically, you can see there are directed edges from C to A to B, B to C. Like you can represent many things. For example, as I said before, you can represent a road network. For example, these are the cities. A, B, C, D are the cities, and the edges are the roads between those cities. Like for example, from A city to B, C city, there is a road. From C to A, sorry. From C to A, there is a city. From A to D, there is a road. Sorry. So like that, like you can represent a road network like in graphs, and another thing you can represent is flow networks. For example, let's say there are sinks and there are like taps, and that is like water flowing in, and you can represent pumps with the edges and sinks and like those things using nodes, and you can also represent dependencies. So I won't be like like these two stuff like this a whole different road networks are the most common one you get PSTM. Most of the like many questions present these like there isn't a like a specific data structure to represent this, right? Or in all the previous cases, like in list, in arrays, in sets, in the like maps, and in all those cases, in stacks, even queues, there was a specific data structure. And but in like graphs, there isn't a specific data structure. Like you have to use the data structures you know to represent them. And there are several ways. For example, I have shown here two. One representation is a matrix representation, which basically saying, okay, there's a matrix in the table, and if there is a road like edge between two nodes, we will put the weight or the weight or the number. Weight is the number in this edge, so we will put the weight in the table. Like for example, since there is a edge between A and B, we will put the weight 1 in the table. Likewise, you can represent the graph in a matrix representation. The only problem is, like there can be like many empty spaces, and because of that, like you might not have much memory. Like for example, if there are like more than 1,000 cities or nodes, then this might not be the best representation. So for that, we have list representation, which means, okay, from A, there is a road to B, which has the weight of 1. And there is a road to D, which has a weight of 3. Likewise, you can use the adjacent city, so adjacent nodes in a list representation. Uh, both representations have their uses, but this is the most common one. For example, I use mostly this one, unless obviously there is a specific use case for this one. And another variant of graphs is a tree. tree is a data structure that basically contains a hierarchical structure. It is a graph, but it doesn't have any cycles, and the whole graph is connected, which means that there is a like you can start from one node and go to every other node from there, and also uh, there won't be cycles. Like you can start from one node and you can't come back to here. Like there are no cycles basically. So like this data structure is also used in many computer programming competitions and many questions. This is very similar to graphs, but the thing is, because there are no cycles, like there are set of algorithms associated with trees specifically. And another thing is, if the tree is balanced, then time complexity for most operations will be log n, which means if you are like coming back to the time complexity graph, in n log n, if you are, let's say, the expected time complexity is n log n, which means, which probably also means that there is a tree data structure, a balanced tree data structure that you have to maybe query n times, something like that. So because the time complexity for most operation is log n, this is also like very commonly used because it's also fast. Because unlike hash sets or hash like maps, there's no like unique requirement. You can store elements in depending on the tree type. You can store elements there, and still the operations will be fast. So the most common variant is the binary search tree, and there are other advanced ones as well. Mm, yeah. And another like specialized tree structure, we call it heaps, which means there are like two kinds basically: min heap or a max heap. In min heap, the topmost, the root element, has the minimum of all elements. In max heap, the root elements will have the maximum amount. So, for example, we can see this is the max heap because the root one is the maximum one, and the advantage of heap structure is you can like always get the uh, maximum element in log n time, and you can add elements to the heap data structure in log n time. So these are very like commonly used for priority queues. So for example, if you have some set of, let's say, elements that you need to uh, like you have to put the elements and get the elements, and there's a certain priority or something like that, then you can use heaps. So in Python, you can easily use heaps because there is a inbuilt heap queue library in which you can like push and pop elements from a heap. So for example, this is the priority, and you can store an element there, and basically you can push element and you can pop there. So for example, in the first pop, you will remove the tree because it has the highest priority, and then it will remove the two. So those are the main data structures that I plan to look. At the end, as I said before, I'll be giving some more uh, like pointers to where to learn more data structures. But most of the cases, these are like if you master heaps, graphs, trees, and hash sets, hash maps, and list of those things, then I think you can actually cover many problems in the competition and in algorithms. Okay, so I here I'll be talking about like briefly going through several algorithms. I won't be like discussing them like internally, like how to implement it or anything like that. I'll be just talking about like what is this algorithm, and maybe talk about the use case. So I have here like only three sets of algorithms, right? So first one is greedy algorithm. So greedy algorithm is basically making, so here I have said the definition or something like that. So here we say greedy algorithm is locally, we take the local optimum choice and we hope to find the global optimum. So for example, in each state, what we do is take a decision without thinking about the future or what happens next. We take a decision and we get to the next stage, and in next stage we also take the like a decision. Likewise, we go through the stages. So let's say iteration. We go to iterations, like each stage taking a local optimal choice, and we hope that it will lead to the correct solution. I will describe a problem next, so you will get a idea of what types of algorithms these are. So pros and cons. So greedy is very easy to implement, and the second one is very important. So you be using greedy algorithms, you can actually get partial results in competitions. Like most of the times, uh, because greedy algorithms are very easy to implement, you can get partial scores using greedy algorithm. You won't get the highest score, and maybe you will get zero. But sometimes you can get a point, 10 points or 20 points using greedy algorithm. That's mainly because it has a very low time complexity, because you don't think about the future, right? You don't store the future, like you don't store the values and think about, okay, what choice should we make at this stage or something like that. What you do is basically in stage take a decision and go to next one, and likewise you are always iterating. It is because of that it has a very low time complexity. And cons is obviously not every problem can be solved using greedy approach. And if there is a greedy approach, sometimes it's very hard to find it. So this is a problem, and I want you guys to give me the answer. So this is the problem we call this fractional knapsack problem. Basically, given weights, values of 10 items, we need to put this item in a knapsack of capacity W to get the maximum total value. So basically, think of it like this. So there is a burglar, and he wants to rob a store, and he comes with the knapsack, which has the weight of it can carry up to 50 kilograms, right? And in this shop, it's a small shop because so there are only three items. There are this one which has uh, 20, let's say 20 kilograms, and it values 100. That whole 20 kilograms will value 100. And then there is another one which has 30 kilograms, weight of 20, and it will value, this has the weight of 30, and the value is 120. So the robber can only carry 50 kilograms. He can't carry more. So he needs the optimal way to get the most value, right? So what is the solution he can take? So can you give me the answer, or maybe comment or something like that? Basically, what is the maximum value? Let's say maximum value that the robber can get. Uh, is there a comment section or something? Okay. Okay. I think the comments are locked or something like. Yeah. Is there any? Can you some people hands, maybe show hands or something, if you can answer this question? So if you have weights and these values, what is the maximum value that the robber can take with the 50 kilogram knapsack? Uh, I'm not sure if you guys can answer in this one, so I'll basically go to the answer. So the best approach in this one is like the greedy approach. Greedy approach is basically we don't think about, okay, what if I took 1 kilo of this one and 1 kilo of this one. Like you don't try the combinations or anything like that. You simply calculate the value of unit. For example, in this one, value of a unit is 5. and in this one value of unit is 6, and this one value of the unit is 4. So basically, calculate the value of a unit, and you take maximum amount of the highest value item. For example, this one has the value of a unit as 6, so you will take the whole 20 kilograms in, and the next one would be this one because it's at 5, so you will take whole 20 kilograms in, and for the next 10 one you will take from here basically. So you will get 120 plus 100 plus 10 kilos from here, which means 40, right? So 260, that will be the value you can take. You can try other combinations, you will see that all other combinations will yield a less value. So we call this problem fractional knapsack problem, and the solution is a greedy one because you didn't think of, okay, what if I carried 1 kilo of this one and 1 kilo of this one and two of this, and like you didn't think of any combination. You just look at the item and calculate the ratio, and based on the ratio you took the decision. So those kind of approaches are called greedy approaches. And another approach you can have at algorithms is divide and conquer. Basically, you divide the problem into small subproblems, and you basically solve each small subproblem and then combine those together. That's the basic idea. So merge sort is a popular example for this. So what happens in that one is, if you have an array, so this is a sorting array, right? Sorting algorithm. So what you have is an array. So you have to sort it. What you do is you basically split the array into two. Now you have two arrays, and that is a small array, right? So you have an array of seven elements, and you divide that into two. So which one has 4 and one has 3. Now you have another array of 4 elements. So you can use the same approach that you use here to sort this. So assuming that you will like recursively call it and it will be sorted. Like we can sort that small array, and then you can sort this small array as well, and then you can combine them. For example, now these are sorted, so you can basically sort this one. So you can put 5 there, and like you can basically merge those two. And this one we call it like call as divide and conquer approach, because in this merge sort we basically what we do is basically split the bigger problem into two small problem, and like solve those two problems, and then combine the answers of those solutions together to get the answer of the main one. And similarly, quicksort is another one. So in that one, it's very similar. It is also another sorting algorithm. And what we do is we basically pick a pivot element, and we take a pivot element. We partition the arrays into two elements, and basically the left side and right side we sort them again recursively and combine them together. So you can read more of these things later, I guess, because a greedy approach, divide and conquer approach, and then the dynamic programming, those things are very common. Like these are like basically how you can think of a solution, right? So now you know there is something called divide and conquer, then and now you know there is something called greedy approach, right? So because of that, maybe when you are given a problem, now you can think in that manner. Okay, does this problem have a greedy approach? Do can I think this problem at all and take the easy way out, and maybe it is the correct answer, so something like that. So in the competition, try to like apply this knowledge. It doesn't like the theory part is not much interesting per se, but the application part is like if you try to solve problems, you will see that it actually is a pattern of thinking. So another approach, as I mentioned before, is dynamic programming. So dynamic programming is basically recursion, but the only thing is you basically memorize. So if the problem has smaller subproblems which have like basically share. The subproblems are shared. In that case, we can use dynamic programming. And I won't be going into details about this as well, but search this up, maybe Google it, and yeah, try to learn. And as the final topic, I won't be like conducting the session much longer than this. So, as the final topic, I will be discussing some tips and tricks, and then I'll actually ask you to present any questions or things you need to know. And basically, so one like this is this is how I approach a problem, right? So when I get a problem, what I do is read the problem well. So you can actually follow these steps, but not a guideline. This is how I personally approach a problem, but and I have found that it actually works very well. So what I do first is I read the problem well, because in every competitive programming competition they give a huge text. It says sometimes a story or something like that. So, for example, they have Alice and Bob and they do stuff and whatever. And it's like very like the actual problem is like hidden inside the text. The they actually show like many unrelated stuff in there, and they hide the actual problem with fluff details. So basically, the first step is to read the problem well, and understand what the problem, like the challenge expects from you. So basically, ignore everything that doesn't like isn't necessary. Basically, ignore that whatever isn't necessary for the answer, and try to get to the core problem. So, for example, try in abstract terms, what does the problem expect, and then what I do is once I read the problem, and I try to understand the core problem, and what I do next is basically code the inputs, because at one point or another I have to code the inputs at some point, right? So what I do is I code the inputs first, because when I code the input, I found that whenever I code the input, I get another small insight into the problem as well. Because when you code the inputs and you understand, okay, these are the stuff they are giving you, and because of that, like it helps to understand the problem better for me, and I hope that it will be like helpful to you as well. But because when you code the inputs and read the question again, it will the problem will become more clear, basically. Then what you have to do is basically sketch the algorithm, maybe in a paper or mentally discuss with teammates. Think, hey guys, how to solve this, and don't jump right in. Basically, like you have when you get the question, some people basically start coding without even thinking, and for advanced level, yes, because some people, they are practiced to think as they go, right? But as a beginner level, first think what your approach is. Think if the time complexity is enough, or think whether that approach will work out. Basically, discuss with others, and yeah, basically sketch the algorithm, and then try to write the program and test it locally and submit. Obviously, you won't get the all points in the first time, so change the code, try again. That is the iterative process, right? So you have to always like don't give up. Basically, uh, think think more, and basically try to fix the problem and submit it again, and do this iteratively. And so this is in IEEE stream. This is the question format, and it is very similar in other platforms as well. So In this one, you can see the text is here, and they actually give you standard input, basically saying, okay, this is the format of the input we give, and this is the output we expect. And here you can see the constraints. T is between 1 to 5, and is between this number. And sometimes they give an example as well. But example is not always necessary. Sometimes they don't give examples, but in this case they have given. And here you can see the coding window, and there is in every ID there's a way to like change the language. As I said before, most of the platforms they support any language, so language doesn't matter most of the time. And you can choose a language, and in here you can run the example, so submit it. And in HackerRank, this is how it looks. So for example, there is the here you can see the problem, and they give the input format and output format, sample input and sample output examples basically, and the explanation for the examples. And underneath you can see the coding window. So most of the UIs of the platforms are similar. They don't differ much. So you can like practice in one platform, and you can apply that knowledge basically to another easily. And I should put the this slide again because this is a big, like basically big trick that you can like try basically. So basically from the constraints you can try to guess the approach. And some more tips. So if you are stuck, at least try the dumbbell approach. So some people I have seen that they get stuck thinking about the like think of the problem. They think of the problem and try to think the optimal problem in the first go, but obviously it is not always possible, right? So they take time just thinking. They don't code anything, they just think. But that is not also optimum because this is a competition. The target is to get the most points. You don't have to solve everything. What you have to do is to get the most points. So if you think maybe sometime and you didn't get any optimal way to code this, then that's okay. Then try to at least try the dumb approach. At least try to get some points, 5, 10, it doesn't matter. Try to get the points you can because that points will actually matter. And another tip is basically code snippets. So I think this video, yeah. So basically you can code like in your IDEs mostly, you can have code snippets. So if you like basically yeah, like you are coding this stuff regularly, you can save those snippets in the IDE and use them because there are some stuff, for example, taking inputs and outputting inputs. Those things actually you have to code them again and again, right? So for every problem, what you code is the same. So my suggestion is basically have them as snippets or maybe some algorithms. Like for example, you can have binary search algorithm and you can code it beforehand, right? You can code it beforehand and keep it somewhere. And maybe some data structures, graph data structure, how to take a graph data structure input. You can write it beforehand, save it somewhere because in most of the competitions you can access internet and you take your own laptop and that's fine because it's not cheating or anything. You can actually use the code snippets and code you wrote before because those are like standard algorithms, right? You don't have the like you don't pre-program the answer. You are just keeping some algorithms or data structures, and you can basically, if there's a need, you can actually copy paste them into the ID and use them because don't try to invent the wheel every time you go to the competition. Like you don't have to type in every word or every character. You can copy and pasting is okay because what they want is the algorithm knowledge, right? It's not the whether you can type most characters in the predefined time. It's not the thing they test. They actually test whether you can apply algorithms or data structures that you have learned before to uh, competition, right? And the third tip is language does not matter most of the time. So always program in the language you are familiar with. Just because one person said, okay, this one is the best for the like competitive programming. If you do competitive programming, this one is the best language. Like my suggestion is it most of the time is fine. Like if you use Python or Java, or it's most of the time you can do like solve all the problems using every programming language. It doesn't matter. But obviously, if you are familiar with the language, or some language there are like some tips, some tricks, and for example, in C++ or Python, especially in Python, there are some libraries. So you don't have them in another language, so you have to implement them yourself. So in those kind of perspective, yes, some languages they might be like better to use, but most of the time it doesn't matter. So my suggestion is program in the language you are most familiar with, and you can code the fastest, because your language familiarity it's a must, because you can't go into the competition and like search the syntax or something. So you should be familiar with the language. So use the language that you are most familiar with. And here are some books and practice websites. So this book, Competitive Programmer's Handbook. So I have the book link here as well. It is a free book. This one is one of the like most, I'd say, one of the best books that you can have in this domain, because it actually has many. Wait, I'll see if we can go to the link. Basically, it's one of the like this is the book. So this is basically one of the I'd say best books in this domain, because you can have like you can see like there are all the data structures and all the algorithm types, greedy algorithms, dynamic programming, range queries, graph algorithms. Everything is here. The flows, paths, everything is here, and in every one they give the problem and how to solve it and how to think. Basically, this uses C++, but in this book is a very good resource, because uh, if you like at least keep this book when you like go to the competition, because you can actually like even from seeing the table of contents, like you can learn more stuff. Like basically you will gain I think if you actually you want to uh, like become an expert in this like competitive programming, then you have to read this book. So it is a must. So that's why I included it here as the link as well. The second book is the Introduction to Algorithms. This is like a big book, basically containing uh, computer science theory. Basically, this is also a very uh, good one, but obviously this is more on the theory side. This book is more on the practical side. It's more on the how we can use this algorithm in a competition. But this book is more on the theory side. It discusses how to implement data structures and how each algorithm works and internally. So this book is a very like a it's a very large book. This one is small, and but if you want to know the internals, read this book as well. And for the practice, HackerRank is a good platform, and another platform is Code Forces. So in Code Forces, there are like, for example, for every week there is a competition there. So like online competitions, for example, you can join, and there's a predetermined time, and you can actually participate. And it's a global competition. So every week or every month there's a competition in this platform. So if you want to have experience before, use this platform. But obviously the questions in this platform is like very hard relative to the hacker rank problem. Hacker rank problems are a bit on the easier side. So for the beginner, hacker rank might be the best option. But for an intermediate to advanced level programmer, I think Code Forces is a good resource. So yeah, those are the slides that I have prepared. So if you have any questions, I'll be happy to answer. I see that some people have put 240. I think the for that one I said, as I said, you can have actually 260, right? Great. Yeah. Any other? If you have any other questions, you can. Okay, in the parallel, right? So one person asks how important it is to have background in mathematics when it comes to competitive programming. Uh, I'd say when, yeah, yeah, I'd say when you are starting out, it's okay if you don't have a background in mathematics because, like, you can go like most of the way there without having like writing a single equation or anything like that. But when it comes to advanced stuff, obviously you need to have a strong background in mathematics because some of the questions that you get in some competitions, they rely on some mathematical theory. So, for example, combinations. That is a very popular type of question. So, those kind of those for those kind of problems, you need to have like the idea of combinations and number theory and those stuff. And in the book as well, I think there is whole section still like dedicated to the mathematics. So if you don't have a background in mathematics, it's fine. You can like read those books and get an understanding basically. And I think it will take you a long way. But obviously, for advanced topics, you need to have an idea of the mathematical stuff. And how to figure out when to use which data structure out of those. So basically, as I showed in the slides, some data structures are good, like they have time complexity, right? For example, as I said before, if you have to search an element in like in a repeated manner, for example, in a loop, you have to search an element if that element exists. In that case, use a set because sets are very great for searching, basically constant type. So in that case, use a set. And if you have some kind of, let's say, ordering based on some priority, for example, you have some elements in your like basically in the question it says, okay, there are a set of people like this, people come in and people go out, and you have to pick the most priority person out of this time or something like that. It's, if it contains some notion about priority, then heaps are an option, or you can use a sorted array. It is also another option. And if your problem has, as I said before, roads and maybe some flow networks, so if it has maybe, let's say there are people and they have friendships, so there is some nodes. If you can identify some nodes and links between them, it can be friendship. So I have this person as this as friends, and that person has these people as friends. So likewise, there is a notion of like links, right? So if there's a notion of links, then you can use the graphs. And because basically use graph algorithms, there are a lot of graph algorithms you can use. For example, if you want to find the shortest distance, for example, this is a question, right? So I have friends, I have A, B, C has friends, and B has these people as friends, and C has these people as friends. So the problem details, okay, we will give you the people and their friends basically, and you have to reach a person. Basically, I have to reach the person X, X, and what is the shortest way you can reach him? So by talking to the minimum amount of people. So basically, in that case, what you have to do is basically find the shortest distance between two nodes, right? And for that, there are various algorithms. Basically, all those graph algorithms are already like very. If you search in the net or even in the book, there are a lot of graph algorithms searching the shortest distance and finding if there are cycles, those kind of things, right? So try to apply, if your problem applies to those kind of scenario, then you can use a graph. And if there is a notion of hierarchy, or if there's a notion of, let's say, a graph, but it doesn't have any cycles, then you can use a tree. And yeah, likewise, it depends, right? You can't always say this data structure is good for this situation, this one is good for this situation. It depends. If you like do many questions, then you will actually when you do questions, you will understand, okay, for this situation, this data structure is better. You can actually refer to that book as well, because it explains what data structures to use. But yeah, I think I answered that question. Another question is it more important to be proficient in few type of data structures, or is it more important comfortable in a wide range? Very good. I'd say you need to have depth in certain stuff. There are certain things that you need to have the depth, but you need to have the breadth as well, because you need to know at least like this. There is a topic like this, so that knowledge itself is very important, because if you know, okay, if for a flow network I can use this algorithm, if you know that already, even if you don't know the algorithm, like you haven't basically tried it before or anything like this, but if even if you know that there is a algorithm like this in existence, if you get a problem like this, you will understand, okay, oh, I can use that, and maybe Google it then, and I'll try to apply it there, then and there, even if you haven't learned. But what happens is, if you don't know, even if that exists, like it happened to like me as well, like if you don't know that this thing exists, right? So what you try to do is, you basically try to apply the thing you know into that problem. But in that case, it won't work, right? The problem in timeout, or it will take a huge amount of time to implement, and later you will see, oh, okay, this there is this topic I didn't know, which can easily solve that problem. So to stop that from happening, what you need to have is basically a good breath. So that's why, as I previously mentioned, as it, that book is very good, because it has all the like I share the screen again. It's like ad for that book now. But yeah, that in this book you have all the topics, right? Read the topics. I'm saying just read the topics. Don't try to like, you don't have to read the content even. Just from reading topic, you will understand, oh, okay, so there is an algorithm for this. So for example, mm, there is an algorithm coin problem, task and deadline, minimizing time. So when you get a task and deadline related problem, you can go to that section and actually try to read it. Like, so I'd say breadth is important because of that. So you know this sort of problem exceeds, this sort of solution exceeds, but obviously you need to have that knowledge on some stuff, basic stuff, graph, especially graphs, and data structures. That depth on those things is actually very important. And yeah, I'll put the slides now. Mm, I'll put the slide in the chat. Can someone confirm whether it is accessible? Sorry, I sent a direct message also. Okay. Mm, can someone like confirm whether this link is accessible? Yeah, I think, yeah, okay. I see people joining. Okay, okay. Yeah. Okay. The next question is big connotation dependent on the programming language? No, no. Big connotation basically it says for an algorithm, even for pseudocode, there is the worst case. Basically, it's saying uh, what is the worst case number of operation it has to do. So it doesn't depend on programming language. It basically depends on the algorithm. So for example, if you have a loop, if your program is just a loop, regardless whether it is in Python or Java or C++, big O notation, the big O notation is big O of n. That doesn't change. So big O doesn't change from the programming language to another. Obviously, there is a hidden coefficient. So if you learn about big O notation, you will understand. Like if you learn about it in theory, you will understand what it says is basically some kind of upper bound, right? So that is the coefficient. That coefficient is removed, but that coefficient changes. So for example, if there is a item 10 items and it takes 3 seconds for C++ algorithm, uh, I'm just saying, okay. Uh, if there are 10 items and it takes 3 seconds for C++ algorithm, and for 100 it takes 30, which means it's a linear growth, basically big O of n. For Python, for the 10 elements, it will take maybe 2 minutes, right? But for the 100, it will take 20 minutes or something like that. So basically, the growth is the one. What we talk about is the growth. It doesn't talk about the base case. Basically, uh, C++ algorithm, if you implement the algorithm in C++, obviously it will run faster. The same one implemented in Python will run about like 100 times or so slower, right? But in the competitive programming competitions, the platform, mostly the platform, for example, in HackerRank, they give a larger time window for Python and a smaller time window for C++ algorithms. What they do is, if you pick, like in the IDE, if you pick C++, your program will time out in, let's say, 100 milliseconds. And if you pick Python, your program will time out in, let's say, 2 or 3 seconds. So they give a large amount of time for different time for different programming languages, because obviously programming language there are like faster ones and slower ones. But as I said before, the point of these competitions is not to like measure if you know C++ or Java or Python. What they test is, do you have an idea of algorithm and do you have an idea of data structure? So they don't actually try to like constrain you. They actually give you time more if your programming language is slow. So you can use any programming language, and no, the big O notation does not depend on programming language. But they actually tested the big O, the time complexity in each platform. Is documentation loud during the competition? No, you can't use any like other than the inbuilt ones. For example, in Python there are like several, right? For example, collections, and in for binary search there is the one, and like heap there is the one. There are a lot of inbuilt libraries. You can use them. But for example, you can't use NumPy. You can't use IPyO. Those things you can't use. Like there are a set of libraries, internal libraries that they allow, and those are the only things that you can use. For example, all the inbuilt ones, they are all very fine, like you can use them, but you can't use any third party programs or anything like that. Like you have to use the inbuilt functions basically to implement the problem. Okay. And another question is, if we encounter problem during a competition, can we seek help from a AI chatbot to resolve it? I think like when we were in university and we were doing the competition, there wasn't this AI chatbots or anything like that. So I'm not sure how it applies to a competition, but what I think is like these AI chatbots, they are good. I'm not saying that they are useless. Um, there are like you can use them basically to search something, like for example ask some maybe what is the direction we can take. But the problem is some questions, like most of the questions you get competitive programming, they are like very like uh, what do you say, like they are not straightforward, right? All the questions have a certain amount of fluff around it. So when you like what I think is maybe if you give something like that to a chatbot, it will spit out some answer, but I'm not sure whether it will be the correct one, because most of the time, even the codes, even for the smallest problems, the code that it gives out is it appears correct, but because it's what it trained, right? It basically trained to give a good enough answer, right? So it will give a good enough answer, but it won't be the most correct or best one. And I'm not sure where maybe if the competition allows chatbots, you can use it to ask for some help. For example, you can say, if I have a flow network like this, what is the best way to find the maximum flow in this diagram? Then it will give the algorithm name, right? So you can go start from there, and you can search it and basically research it. So you, in that way, you can use AI chatbots. But I'm not I don't recommend actually to depend on AI chatbots solely in this kind of competitions, because I'm not sure whether it will work. And is documentation not allowed? I answered that. I am a first year undergraduate. What is the best language to start learning data structures and algorithms? If you want to learn data structures and algorithms, first obvious answer is Python, and then I would say something like for if you are learning solely for competitive programming, right? If you want to learn for competitive programming, if you are a beginner, I'd say start with Python or C++, because those two are the ones that have the most online like online help. For example, for this kind of algorithm, if you want to find an algorithm, you will like if you use C++, you will certainly find the solution everywhere. Like it is very easy to find a sample code or something like that. But for example, for Java, it is less. And but if you are learning not just for the competitive programming, but you are learning for your university degree, I'd say go with what the university offers. For example, Java is a popular one. Java, Python is also good, because uh, in data structures and algorithm, it's all about the abstract idea, right? It, as I said before, the language doesn't matter. What matters is the idea of how what is the heap, how does it perform. So that idea doesn't change whether you implement it using a Java, like using Java or Python. It doesn't matter. So if so, if you already know Python or Java or something like that, use it. If you don't know any language, then I'll say start with Python, because it's the very easiest one. But obviously, that answer is very it's the not the objective answer, right? It's subjective one. It's my opinion. in my opinion, is to like start with the easiest one. So it's the Python is like, in my opinion, the easiest one to learn data structures. And yeah, can you recommend the first approach for a beginner to enter competitive programming? And so I assume this is talking from the perspective like you want to like uh, uh, you want to enter a competition, right? So my suggestion is okay. Now you are in a like you know some algorithms, right? So assume you know some programming language, but you don't have any experience in competitive programming. I'd say enroll in those as I showed in the slide said, there's a platform called Code Forces. So enroll in those competitions. Try to like solve those problems and go to HackerRank. And there are a lot of questions there. Try to solve them. Start with the easiest one and try to solve them, and then move to medium. Medium, if you can perform medium, that means that's really great because if you know the medium, if you can solve medium questions in and whenever there is a computer programming competition, for example, CodeRally1, no, there are like many other computer programming competitions out there. Even if you don't have an idea, any idea of how to like computer programming, you know the language, but that's it. It's fine. I'd say go to this competition because that's a whole different experience, right? Like you are like in that moment 12 hours or 24 hours solving the problem. Even if you solve just one question, that will be enough. So I remember like in my first competitive programming competition, I actually participated in my school time. So in that first one, I only managed to solve one question out of I don't remember like 10 or 15 questions. So that like it doesn't matter. Try to get out there. Try to basically solve as much as problems possible. Try to practice more and more, and like it's basically practice makes perfect. Basically, try to practice, and with time you will actually see patterns. So you when sometimes there is a situation now. Whenever I see the problem, I can understand. Okay, so this is the adaptation of that question I thought before. So you will actually notice a pattern as you go on. It won't happen like overnight. You have to practice. So if you are new to computer programming, get out there and really go to competitions, go to online competitions and do online problems. Yeah, that's the best advice I can give. Does the actual runtime of a solution matter beyond getting it accepted? Like if I can come up with two solutions, say 30 milliseconds and 50 milliseconds, both within submission requirements, will the extra effort to implement the better one matter in any way? Assuming you get the total score, basically, it for each problem they will assign a score, right? So in most competitions, it's a fixed score, basically saying. Easy problems have a score of 30 or 50. Hard problems will have a score of 100 or 200 or 300, something like that. And assuming you got all the test cases correct, like all the code is 100% correct, then it doesn't matter. Like it doesn't matter whether you took algorithm took 30 seconds or 15 milliseconds. So it doesn't matter if as long as all the test cases passed, the program, the efficiency does not matter basically. What matters is the time you took to program it. So basically whenever there's a tie, uh, like I'm talking about the overall, like the overall score. Basically, let's say you solved 5 problems, right? And you have now 150 marks, and then there is another person with 150 marks. What they look at is the last submission time or submission. That's the mostly the time you took to program basically. So that's the thing that will change your rank. And so that's why this is a competition, right? So oh, you have to program the solution that will pass all the test cases fastest. That's the point. So you have to do it in a very fast manner. So you have to type in, like, think very quickly and do it. So it doesn't matter whether it took, the program is 30 milliseconds or 50 milliseconds, it doesn't matter, as long as it passes all the test cases. But if the test cases don't all pass, which means then obviously the 30 milliseconds or 50 milliseconds matters, because some test cases there might be timeouts. For example, if the timeout is 40 milliseconds, what will fail? So obviously in that case it matters, but as long as all the test cases pass, it does not matter. And also there is another type of like, as I said before, like in most competitions, the uh, scoring is fixed, right? As I said, scoring is, for example, for each problems, it will have a assigned score. But there are some competitions it is not like that. For example, in IEEE Extreme, what they have is, they have same score for every question. For example, 100 points for every question, no matter hard or easy, it is always 100. What happens is, whenever people solve the problem, the score goes down. So when more and more people solve the problem, the score for that will gradually go down. So the hardest problems where there is only one, maybe, let's say if you are the only person who solved that answer, then you will get the 100 points. But if there are like two, you will both get 99 points, something like that. So that's the another type of scoring mechanism that they use in it's a CS Academy, I think, the platform in IEEE Extreme. But most competitions, when they are using HackerRank mostly, in HackerRank, I think it's mostly the fixed scoring. Do we need to focus on error handling in competitive programming? By, like, if you mean by error handling, like, for example, if you take inputs, do I need to check whether the number is, if the input is a number? You don't have to, like you don't get extra points if you do, like, error handling stuff. If you don't, like, you don't get extra points if you do comments. Like, if you, just because you have your code has comments, it doesn't, like, you don't get any point for that. What matters is coding the fastest. It doesn't matter if your code looks beautiful or ugly, it doesn't matter. So if your variable names are just one character long, or you have like descriptive names, it doesn't matter. What you have to do is code fastest the correct problem, correct, basically correct solution. So you don't have to focus on error handling in that manner. But of course, if there are like edge cases, obviously those cases you have to handle, because, for example, there are zero. For example, there are some inputs where it can be zero, and you are dividing by it. And in that case, you have to check if the number is zero. You don't do that. You don't do something else. But uh, error handling for the sake of error handling, for example, if the user gave a different input, or commenting, it doesn't matter, because at the end of the day, what happens is, when you submit the code, it will get submitted into automated system. The automated system will give some hard coded, like, basically not hard coded, but some test cases that the program, like, organizers have previously given. So the we call it the judge. The automated system will basically feed those input into your program and check if the output you give is the expected one. So that's what happens. So it don't give the, like, for example, if it asks for a number, it doesn't try to give a character or anything. So you don't have to handle those kind of errors. So yeah, uh, basically focus on the speed. If you are like, if you can solve a problem, focus on the speed. Otherwise, like, obviously focus on solving the problem correctly. Are there any other questions? If not, I guess we can wind up the um, session, right? If there are any other questions, I think this might be the time to Good day. So as I said before, like already practice, and I think you guys might have visited my the presentation and that the link for the book. And before, like, that book is a godsend. Basically, try to read it if you can, because it's the kind of advanced, but try to read it, and it will actually elevate you to a much higher level. And yeah, and good luck on your competition.
Thank you, sir. I think that's about for the question. So we would like to take a moment to express our heartfelt gratitude to our speaker, Mr. Sunera Avinash. Your time and effort in contributing to our very first workshop at CodeRally 5.0 is immensely valuable. Thank you very much.
Thank you.
Last
Thank you.
but not least, let's acknowledge our valuable title partner, eFutures, who has been with us since the beginning of CodeRally 5. Group photo. Everyone, can you please switch on your camera? Thank you. Um, Tulani Color Tour. Do you have a question to ask from our? Okay. Thank you, guys. Thank you for all your active participation and the enthusiasm throughout the event. It has been a wonderful experience. And thank you very much, sir, for guiding us throughout this workshop. And that will be it for today. Thank you once again for joining us. And we look forward to seeing every one of you in our future workshops at Code Rally and also the final hackathon of Code Rally 5.0. Good luck and have a nice day.